Started.
Hello everyone, welcome to our presentation. Our topic for today's presentation is how to measure the Geneve tunnel throughput number on hardware accelerator DataPath with OVN controller. My name is Haresh Khandelwal and I work for Red Hat Telco and FV Group.
Hey, hi. I am Pradipta Sahoo. I'm working as a senior software engineer at Red Hat, majorly working for OpenStack, NAP, and performance and scale scenario.
All right. So agenda. So agenda for today's presentation is very simple. It's just a methodology which we develop and executed in our environment to get the Geneve tunnel hardware, Geneve tunnel throughput number on OVS hardware offload deployment with the OVN controller used in OpenStack. We would like to present what are the challenges and changes we did and we faced while working with the Trex traffic generator, and what are the challenges and changes we have to do on the OVN side so that it can accept our packet and process the packet and provide us a proper throughput number. With all the things sorted out, we will share the line rate throughput number we got in our tuned environment, and final we will share what are the observation and finding out of this activity.
Okay, so coming to the methodology in typical scenario, like in the three scenario, we can explore that to achieve the throughput and throughput in overlay network like Geneve traffic. So first option we tried with the virtual traffic generator, which is install the traffic generator software as installed in the VM on the same layer 2 domain. But when we try to explore this the throughput scenario, we found that we achieve a very low throughput because of the hardware due to lack of hardware acceleration, which is limited with 6 to 7 million packet per second. Although we have tuned the virtual environment as per the NAP guideline. And the second option, which is like the bare metal traffic generator with having a intermediate gateway host. So the intermediate gateway host is acting as a gateway for encapsulation, decapsulation operation for the overlay traffic. So although it is very flexible to process the traffic without changing the header from the traffic generator, and there is very minimal requirement changes required in the device under test, but the intermediate gateway host is majorly taking a cycle to process the traffic, which is impacting to the overlay the overall performance. So to avoid this dependency, we explore the bare metal traffic generator, the software in the traffic generator option, like the existing library, whether there is any option what we can explore so that the traffic generator itself can encapsulate the packet and it can process without having any intermediate gateway host. The OVN controller can directly acknowledge the packet to further process to the VM. So we tried the scenario we explored the Trex library option with how to encapsulate a packet with the Geneve header, and we able to transmit the packet without having any additional gateway host with meet to the same line rate requirement. And we are the traffic generator established in outside of the OpenStack cluster, so that OpenStack there is no dependency of the OpenStack environment to manage those things, manage those traffic generator, and we are able to compose that packet for multiple VMs, so that in tenant environment it can able to scale. So coming to the protocol requirement for the Geneve in a typical scenario, it's required a outer header and the protocol the UDP header for the Geneve predefined requirement, and the Geneve header which will be carry the option length, the other metadata information like VNI ID, the option data, and there are other parameters. So and at the end, we required an internal header with the payload. The internal header is mainly carry the information for the VN traffic, and the outer header for the end-to-end, like the tunnel communication from the traffic generator to the device and the test tunnel. So this is a sample output of the packet header, how it looks like in the Geneve packet as an encapsulated format. So coming to the network topology, so in our test environment, we tried with a very minimal setup. This is the traffic gen install, the Trex software traffic gen install on the bare metal node, and other two node have mainly designed for the OpenStack, where the controller and the director, this is the deployer of OpenStack, is installed as a VM in the KVM host, and the compute node is a bare metal. And this is the typical network topology for the control plane and data plane. And the bottom layer, which is the network for the tunnel network, where the traffic gen has configured with the 4 interface, where it will be injecting the traffic for like each interface is acting as a tunnel endpoint, and it processes the traffic to the duty on the same layer 2 domain traffic, layer 2 domain network. And coming to the software specification in OpenStack, we use the like 16.2 release, which is based on the like upstream train release cycle, where the base operating system is 8.4, which is like the kernel version is 4.18. And in Open vSwitch side, we use the software switches in duty, like Open vSwitch 2.15, including the other Open vSwitch dependency package of OpenStack. And in OVN, we are using the latest version of OVN, which is 2021 package. So we recommend also, if there is any, this test should be executed on latest version of Open vSwitch and OVN software. And the Trex version, we tried this on bare metal 8.4 kernel, which is the version we used, like 2.89. Yeah, Haresh.
All right. Thanks, Pradipta. Okay, so as Pradipta told, in this methodology, the way we selected is we omitted OVN gateway in between, which comes between our duty and our traffic generator. Now, when you remove OVN gateway from the picture, then the question comes: who will insert the metadata, OVN metadata, in the packet, and who will take care of the Geneve tunnel? So this, if we take OVN gateway out of the picture, we have to do inside the Trex now. So Trex underlying use the SCPy libraries to build the packet. So the Geneve packet builder available in that version of the SCPy was not working fine with the Geneve option header, which I have highlighted in the red color. So the Geneve options like class ID, type, sum of reserve bits, and the length and the data bit. So data is what the metadata here you can see, like 0004. This is the ingress port number, and 0005 it's egress port number. So in OVN packet processing, the input and output port decided based on this particular data. This is the metadata. So we had to do these changes in the SCPy library. We submitted PR upstream as well, and we used this particular patch in our methodology to build a entire Geneve packet with the proper Geneve options and metadata as we required. Can we go to the next slide, please? All right. So the initial challenge with the OVN controller is it will simply reject all the packet, which is like not proper VLAN header. It's like not the tenant VLAN. It doesn't have the Geneve metadata information. It doesn't have proper Geneve header, or inner packet is wrong. That means in our duty, the VM what we have, it should have the packet should have information to reach to the VM. Without that, it will just drop the packet. Now, so what we worked on this, so we provided, so we considered now our Trex traffic generator as a part of the cluster, but not being in the cluster. So we configured the interface there, and we put that into a tenant VLAN. We assigned the IP address of the one of the IP address from the tenant network, and we configure the upstream switch with the proper VLAN so that DUT to traffic generator traffic can pass through, and we put proper metadata fields in the packet builder of the Trex. So this is the Trex side. Now what we did on OVN side. So as I told, our one of the aim is to keep Trex out of the cluster. Now if you keep something out of the cluster, what is inside the cluster won't recognize this. So we did some tweak there. So on our DUT, we add the Trex host into a southbound chassis as a one of the tunnel endpoint. So now when packet comes with the same tenant network IP address, same tenant VLAN, it doesn't just reject the packet. It considers the packet as being the part of the network. So the Geneve layer, tunneling layer, we are resolved. But how about the VM? So VM, which is behind the Geneve tunnel on the DUT. So to reach there, we created one more logical port on the DUT southbound chassis and attached that to the Trex tunnel endpoint. So that means we have one logical point behind the Trex Geneve, and we have actual DUT with the Geneve tunnel and actual VM. Now when the packet comes, it can be processed and it can be reached to the VM, and when VM respond, it can be traversed back to the traffic generator. So this way we can achieve to and fro round trip of the packet, which can help us to collect the throughput number. Now the metadata we have to use here is we have to be very smart because it has to belong to the same VM to the network where the VM belongs. We put our Trex logical port into the same provider network, so tunnel remains the same, and the ingress and egress output port number which we required on the OVN side, we have manually entered it. We can get it via OVS few OVS command. We can get what are the port numbers OVS considered. So we have to put that into a packet builder, and we have to just send the packet. We don't require any other changes in any OpenStack services and on the DUT apart of these changes which I told you. The VM which we used on the DUT is a test PMD, so we can test PMD takes the benefit of the fast DPTK data path, so we can have a line rate, line rate throughput number. Yeah, shall we move to next slide? Yeah, please carry on, Pradipta. You are mute, Pradipta. You are mute.
Sorry. So I'll try to explain like what Haresh has already explained in the previous slide in a high level manner. So in this is the typical design of what we have between the Trex and OpenStack compute node from OVN controller perspective. So OVN controller, although we have like the Trex configuration is not managed by OpenStack cluster, but as a typical SDN behavior, it's required to if we need to communicate between outside traffic to OpenStack cluster, it's required a tunnel endpoint gateway to recognized by the OVN controller. So in that perspective, in OVN southbound database, we have created a southbound agent which will be hold the information of Trex endpoint configuration. The configuration means what type of encapsulation methodology packets it will be recognized, and what is the IP tunnel endpoint IP. So if in this diagram, the southbound database is carrying all the Trex individual port as a southbound agent, and it's configured with the Geneve encapsulated packet and also the information carry of the IP. So that and already in OpenStack side, OpenStack already created a southbound chassis in the database of the compute node, so that all the IP of the compute node and Trex in the same layer 2 domain. Like here, the example is like 172.17.2 network, and this is a typical design of OVN controller in terms of mapping of Trex endpoint. And this is a logical view of tenant network mapping. For an example, we wanted to process the traffic to from tenant Trex to compute to VM and the same compute node. So we assume that there is already two VMs are created, which is having a port number defined by OpenStack neutron, and as a OVN controller perspective, each port have a logical port mapped to the respective southbound chassis, like the compute chassis, and it has every logical port have a unique tunnel key, which is belongs to the same chassis database. And in that way, we have to create individual chassis manually on the respective the Trex chassis port, which I have already highlighted in the color code like yellow color. And this, for an example, like I have created 4 tunnel key, which is the 4 logical port I have created, which is mapping to we have mapped to the respective chassis of the Trex port. And in OpenStack side, it's already been assigned by the ML2 OVN, which is the logical port of the VM network. And now, like we have to when we define the data field in the Geneve encapsulation SCAPI header. So here the key point, like Haresh highlighted, the data field is carrying the ingress port and egress port. So the ingress port is mapping to the, for an example, if I wanted to send the packet from tunnel key 4 of tenant network 1, and packet will process from tunnel key 4 to tunnel key 2 to the test PMD VM1. So the Geneve header will carry the tenant network VNI ID, which is 1, and the tunnel key mapping in the data field side, which is tunnel key 4 and 2. So that then OVN, once the packet is landed to the endpoint of the duty, which is the compute chassis, then OVN controller will recognize that this packet belongs to this chassis, and it has the information of this tenant network and the tunnel key ID, so that it should be landed on the test PMD VM1. So in that way, when the reverse packet will be come from the tunnel key 2 to the tunnel key 4 of the second endpoint of the Trex, then the OVN controller have already information what is the egress path of this network, so that it can forward back that return back that packet to the respective chassis, and the outer header also get changed accordingly when the packet is moved towards to the from duty to the Trex. And this is how the tenant network we map like with 4 tenant network, and which is packet has distributed with 2 VM, and all the packet is isolatedly all the like communication has isolated between each other, and the packet is like processed without having any kind of collision. So this is a end-to-end packet journey between the Trex and duty, how the packet is processed from the Trex, like with the SCAPI header, and how once the packet is landed to the duty, how the packet looks like. Initially it is having the having the Geneve encapsulation header, and as once it will be processed through the Geneve sys interface in the device under test, then it will be decapsulate the packet with the actual form of packet, and it will be based on the header, it will be processed through the test PMD, and the test PMD will be forward back based on the forwarding mechanism, like we use the IO mode, and in that way it will be forward back to the second representer port. And again, Geneve, once it will process through the OVN and OVN OVS layer, and it will be encapsulated encapsulated again the packet, and with the destination header and the Geneve header, and it processed back to the Trex second interface. So in that way, we tried the unidirectional and the bidirectional, means the second interface to the first interface, like as a cross network communication. So this is how, based on our network topology, we try to, like, I can share like what I explained, like the logical mapping. So we first tried to process the packet in the first interface of the Trex, and it will process via this way, like it will process to the VM representative of VM1 and it back to the second port, and again we process the second port to the first port in the Trex in accordingly. And these are the network is belongs to the individual tenant network ID. So we manually have defined the Geneve encapsulation header when we process the packet from the traffic generator, and this is how we have processed the second and third packet from the respective interface of the Trex. So in this way, we have like calculate the cumulative performance of the Trex, like and the transmit rate and the receiving rate. And we started the test with 128 byte frame size, because the packet of the Geneve header itself have 100 near to 108 byte, and we are targeting to use as a 50% bandwidth, because our the higher network card, and based on the like our current configuration, we limit our configure we try to target our performance of the 50% line rate, and in future we'll try to like increase based on our scale, like once we have the environment in a scale manner. So in the 50% line rate, we achieve a 0% drop, and we achieve the actual line rate of transmit and the receiving side. So if you notice that the Trex transmit rate and receiving rate, it is appropriately matched without having any drop, and we have and in this way, like in the 128 frame size, we achieve like 42.25 million packet per second. But when I try to like in jumbo frame, like 9K MTU, it also we achieve like 0.69307 Mbps rate. So this is how we measure the performance in like Trex to device under test in same layer to on same layer to network to evaluate the best performance of Geneve. And in that way, like we concluded this, we can achieve the similar performance, we can achieve the same performance without having any intermediate host in this topology. So we are expecting like if we can in Trex have the like upgraded some mechanism in the existing library, so that in future we can also do a better research on the Geneve and OVN layer from NFV perspective, and it can suffice the throughput requirement with the various traffic profile. Like if we wanted to scale the scenario with multiple multiple VMs in the tenant layer, it can be based on the packet header in the SCAPI header. We can hard code it, or we can do some kind of mechanism to populate the header file in the Geneve header, so that it can process in seamless way. And it require a very minimal operator level of changes in OVN controller side to suffice the tunnel requirement. That means the southbound chassis and creating a logical port and mapping to the southbound database of Trex individual port. It's a very minimal kind of command line, like 2-3 command it required to be changed. So in that way, like we achieve this. This is the baseline performance we target, and our next goal is to like integrating this our software like what we achieve in the Trex and the OVN side. We'll try to automate that option in the our benchmark tool so that it will run as a binary search mode to evaluate the best line rate as per as per the like environment topology. So this is how we are planning and we are working on our next goal as well. Yeah, that's it from our side. Thank you so much for attending our session. Please feel free to ask if you have any query so that we'll try our best to answer you. Thank you so much.
Thank you, guys.
Hello, thank you, Haresh, and thank you, Haresh and Pradipta, for giving your talk. I believe that we have one question that was asked in the Q&A. So Flavio Fernandez says, in one of Russell's old blogs, he claimed that Geneve is as fast as VXLAN. Do you think that's still true?
Hey, like we are about to test the VXLAN performance in the similar methodology, but we, as per the theory, like if we compare the VXLAN and Geneve, the VXLAN is having a additional cycle to process the packet like for the source and destination header like in the Geneve like it already has in the metadata. So we are about to test the VXLAN performance and maybe and we are expecting it should be the nearest performance to what we like assume, but we are still in progress for that.
That's good. It'll provide some insight to be able to compare more than one protocol, I think. And once you've done that, we can figure out what do we need to do to make the slow one as fast as the fast one, I suppose. So can we look forward to that in some future OVSCon then?
Yeah.
Great. Let's virtually thank our speakers one more time.